NEC 312.3c addresses the specific scenario of running conductors through electrical panels. According to the National Electrical Code, NEC 312.3c, conductors are permitted to enter the top of a panel board and continue to other panel boards or other equipment. This means that, in general, it is acceptable to pull branch circuits through the top panel to reach the bottom panel, given that certain conditions and best practices are observed. Firstly, it's crucial to ensure that both the top and bottom panels are appropriately rated for the load and the number of circuits they will be carrying. The panel's rating, indicated in amps, should be sufficient to handle the cumulative load of all the circuits connected to it, considering both existing and future circuits. Overloading a panel can lead to overheating, potential fire hazards, and nuisance tripping of circuit breakers. Secondly, adequate support for the conductors between the panels is necessary. While NEC 312.3c allows for the pass-through of conductors, it doesn't negate the need for proper mechanical support and protection. Typically, a conduit or wireway is used to provide this support. The conduit or wireway should be securely fastened to both panels and sized appropriately to accommodate the number and size of conductors being run through it. It is important to comply with NEC Chapter 9, Table 1 regarding conduit fill capacity to prevent overcrowding and potential damage to the conductors. Thirdly, avoiding the creation of tripping hazards or interference with panel access is paramount. The conductors running between the panels should be neatly organized and routed in a manner that doesn't obstruct access to circuit breakers, fuses, or other components within the panels. Conductors should be securely fastened to prevent them from dangling or creating a tripping hazard for personnel working around the panels. Adequate clearance should be maintained around the panels to allow for safe and easy access for maintenance and repairs. Fourthly, consider using a conduit body or nipple at the top of the bottom panel to provide a secure and organized entry point for the conductors. A conduit body, such as an LB or LL fitting, can provide a smooth bend and protect the conductors from abrasion as they enter the panel. A nipple, which is a short length of conduit, can be used to create a direct connection between the conduit and the panel. In either case, the fitting should be properly sized and installed according to NEC requirements. Fifthly, if the branch circuits are connected to circuit breakers or fuses in the top panel, ensure that the circuit breaker handles or fuse holders are not obstructed by the conductors passing through. Clear and unobstructed access to circuit breaker handles and fuse holders is essential for quickly and safely disconnecting power to individual circuits during maintenance, repairs, or emergencies. Conductors should be routed in a way that doesn't block access to these critical components. The NEC contains additional requirements that should be taken into consideration when installing or modifying electrical panels and circuits. Some of these include NEC 110.12 regarding neat and workmanlike manner, which requires that all electrical work be performed in a neat and professional manner. This includes proper labeling of circuits, secure fastening of conductors, and clean termination of wires. NEC 312.5 covers the minimum wire bending space at terminals, which is important to ensure that conductors can be properly terminated without excessive bending or stress. NEC 408 provides requirements for panel boards, including overcurrent protection, grounding, and labeling. NEC 314 addresses junction boxes, pull boxes, and conduit bodies, including requirements for size, support, and access. When dealing with electrical installations, it is always recommended to consult with a qualified electrician or electrical engineer to ensure that the work is performed safely and in accordance with all applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. In summary, while NEC 312.3c permits conductors to pass through panel boards, it is imperative to adhere to best practices and other NEC requirements to ensure a safe and code-compliant installation. This includes properly rating the panels, providing adequate conductor support, avoiding obstructions, and using appropriate fittings for conductor entry and exit. Always consult with a qualified professional for specific guidance on your project. The proper ampacity of conductors is also critical for safe and reliable electrical systems. Ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. Several factors influence a conductor's ampacity, including its size, insulation type, and the ambient temperature in which it is installed. The NEC provides detailed tables and guidelines for determining the appropriate ampacity for various types of conductors under different conditions. Overcurrent protection, such as circuit breakers and fuses, is designed to protect conductors from overloads and short circuits. These devices are rated in amps and are selected to match the ampacity of the conductors they protect. When a circuit draws more current than its conductors are rated to handle, the overcurrent protection device will trip or blow, interrupting the flow of electricity and preventing the conductors from overheating and potentially causing a fire. The NEC specifies the requirements for overcurrent protection in Article 240. Grounding is another essential aspect of electrical safety. A grounding system provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to quickly trip and clear the fault. Grounding also helps to minimize the risk of electric shock by providing a reference point for voltage. The NEC outlines the requirements for grounding in Article 250. Proper grounding techniques include the use of grounding electrodes, equipment grounding conductors, and bonding jumpers. Bonding involves connecting metal parts of the electrical system together to create a continuous electrical path to ground. This helps to equalize voltage potentials and reduce the risk of electric shock. The NEC provides specific requirements for bonding in Article 250. Surge protection is designed to protect sensitive electronic equipment from voltage spikes and surges. Surges can be caused by lightning strikes, utility switching, or other electrical disturbances. Surge protective devices, or SPDs, are installed at the service entrance or at individual equipment locations to divert surge current away from the protected equipment. The NEC addresses surge protection in Article 280. Arc fault circuit interrupters, or RFCs, are a type of circuit breaker that is designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors or to ground, creating a spark or arc. RFCs are required in many areas of the home, such as bedrooms and living rooms, to provide enhanced protection against electrical fires. The NEC requires RFCs in specific locations as outlined in Article 210.12. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. The NEC requires GFCIs in specific locations as outlined in Article 210.8. The electrical wiring methods refer to the different types of cables and raceways that are used to run electrical conductors. Common wiring methods include non-metallic sheathed cable, or NM cable, which is commonly used in residential wiring, metallic conduit such as EMT, and rigid conduit, which provides mechanical protection for conductors, and cable tray, which is used to support large numbers of cables in commercial and industrial applications. The NEC specifies the requirements for various wiring methods in Chapter 3. Electrical boxes are used to enclose and protect electrical connections. Boxes are available in a variety of shapes and sizes to accommodate different wiring configurations. The NEC specifies the requirements for electrical boxes in Article 314, including box fill calculations, support requirements, and grounding requirements. Electrical enclosures are used to house electrical equipment, such as panel boards, disconnect switches, and motor starters. Enclosures provide protection for the equipment from environmental factors, such as moisture, dust, and corrosion. The NEC specifies the requirements for electrical enclosures in Article 312, including enclosure types, ratings, and grounding requirements. Electrical safety is paramount, and it is essential to follow safe work practices when working with electricity. Always to energize circuits before working on them, use insulated tools, and wear appropriate personal protective equipment, such as gloves and safety glasses. It is also important to be aware of the potential hazards associated with electricity, such as shock, arc flash, and electrocution. The NEC provides guidance on electrical safety in Article 110. Many electrical products are tested and certified by independent testing laboratories such as Underwriters Laboratories or all. These certifications indicate that the products have been tested to meet specific safety standards. Look for the UL listing mark or other certification marks on electrical products to ensure that they have been evaluated for safety. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest version of the NEC to ensure that your electrical work is in compliance with current codes and standards. Continuing education and training are essential for electricians and other electrical professionals. These opportunities help to keep professionals up to date on the latest technologies, codes, and safety practices. Many organizations offer continuing education courses and certifications for electrical professionals. Electrical inspections are conducted by qualified inspectors to ensure that electrical work is performed in accordance with the NEC and other applicable codes and standards. Inspections help to identify potential hazards and ensure that the electrical system is safe and reliable. Electrical permits are required for many types of electrical work. Permits help to ensure that the work is performed by qualified professionals and that it is inspected to meet code requirement. Contact your local building department to determine whether a permit is required for your project. When planning an electrical project, it is important to consider the load calculations for the circuits. Load calculations determine the amount of power that will be required for each circuit and ensure that the wiring and overcurrent protection are properly sized. The NEC provides guidance on load calculations in Article 220. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines on voltage drop in Informational Note Number 2 of 210.19 AN, 215.2 AN, and 215.3. Short circuit current rating, or SCCR, is the maximum amount of fault current that an electrical component can safely withstand. It is important to select components with SCCRs that are appropriate for the available fault current at the installation location. The NEC provides guidance on SCCR in Article 110. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high-energy explosion. Arc flash can cause serious burns, injuries, and even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings. Electrical safety audits can help to identify potential hazards and improve electrical safety practices. Audits should be conducted by qualified professionals and should include a review of the electrical system, safety procedures, and training programs. It is important to maintain accurate electrical documentation, including panel schedules, wiring diagrams, and equipment specifications. This documentation can be helpful for troubleshooting problems, making repairs, and planning future upgrades.